f of x equals 2 sine of x squared plus x minus 2 for x between 0 and 2 pi. Show that f of x equals 0 has a root alpha between 0.75 and 0.85. The equation f of x can be written as this. Use the iterative formula, x to the n plus 1 is equal to this, and x0 is 0.8, to find the values of x1, x2 and x3, giving your answers to 5 decimal places. Show that alpha equals 0.80157 is correct to 5 decimal places. So let's have a little look at this then. I've summarized the question here. Show that f of x has a root first of all. So 2 sine x squared plus x minus 2. So let's write that down first of all. 2 sine x squared plus x minus 2 between 0 and 2 pi, isn't it? So we've got this function f of x. We need to show it has a root between 0.75 and 0.85. So let's have a look at that then. So f of 0.75 first is equal to, right, 2 sine x squared. So we're in radians mode because it's 0 to 2 pi is the domain of f. So it's 2 times sine of 0.75 squared. Close the sine bracket, plus x, so that's plus 0.75 minus 2, which equals minus 0.18, minus 0.18 negative. On the other hand, f of 0.85 now, tap that in the calculator. So all we need to do is toggle back here, change the 7.5 to now the input value of 0.85 here in 2 places, wasn't it? 8, and then we get 0.17, which was small positive. So there's a change in sign. Since f is continuous, f is continuous between the bounds, between these values. And f of 0.75 is negative. I'll just put the abbreviation there. And f of 0.85 is positive. It follows that f of, it follows that a root lies between, basically, has a root. It follows that f has a root. F has a root in this interval. In this interval. Okay, that's the first thing done then. Let's look at part B. The equation can be f of x can be written as this. So we don't need to work it out, it's given. Use the iterative formula. Here it is here. So let's write that down with x0 equals 0.8 to find x1, x2, x3 to 5 dp. So let's have a look at that then. So x to the n plus 1. So x1 is equal to, so we'll just do the first value, it's arc sine. This is part B now, of 1 minus 0.5 times 0.8, because that's the x0, isn't it? And this is x1, and x0 is 0.8, so put that in here. All to the power half, and that needs to be worked out, because we need to write that down. And then we need x2 and x3. So x2 will equal and x3 will equal. And we need to do all these to 5 dp, so let's use our calculator then to do all this work for us. Okay, so the first thing to notice is the first value is 0.8. So I'm going to type in 0.8 and I'm going to tap that to be the equals, which comes up here, and that's now stored as in the answer. So all I need to do now is do a bracket, shift sign, 1 minus, I'm in radians mode, 0.5 times the answer, which was 0.8, which we put in, close the sign bracket, close the bracket at the beginning, and its power half, which is 0.5, isn't it? Okay, so now we should be able to press equals here and get the number. 0.80 to 5dp 802.18. 802.1819. 0.80219. 0.80219. So that's x1. Now it's nice and easy with x2 because all we do is press equals, because this new answer will go into the formula above. And then we get 80133, don't we? 0.80133. And then we get the calculator back up, press equals again. 80167. 0.80167, which is x3. Okay, that's good. So we've got our x1, x2 and x3 then. Now we can move on to part C of the problem. So let's have a look at this then. 80157, it says show that alpha is correct to 5dp. 80157. So C. Now I'm going to press this calculator a few more times to see if it does converge to 80157. Let's see what we get. Yeah, there it goes. See it converging down? So it looks like 80157 will be the value it tends towards the 5dp, doesn't it? So we need to verify that then. So alpha equals 0.80157. So for this to be the case, we need to look either side of the function. So we need to look at the value of this solution. Where is it now? Where's the formula? Here it is here. So we've got arc sine BC part C. Let's look back up at the question. Show that alpha is correct to 5dp. So we've got the iterative formula, which is the solution to the equation. So let's get the original equation, shall we? Fx equals 0. Here it is here. So Fx, so I go back to this original thing then. So f of x is equal to 2 sine of x squared plus x minus 2. Now we need to look at f of 0.80165, and we also need to look at f of 0.80157, isn't it? And then see what happens in these two cases. So let's work that out then. So we've got 2 times the sine squared, sine of the value, x squared, which is this, 0.80155. Close that bracket for the sine. Now that would be, sine squared, isn't it? Sine x squared. So square that. Plus x minus 2. Plus the value, 0.80155. Okay, so that's done there then. Plus x minus 2 equals, so we get a very small negative. So I'll write that down, minus 2.7 times 10 to the minus 5. Negative. So let's note that. And now we go back and we can toggle back and just put 7.5 in, can't we? Here. I'll put a 7 and just toggle back here. And put a 7 there. That's easy enough to do. And we get 8.6 times 10 to the minus 6. Which is positive. So since f changes sign, and is also continuous in this interval, f has a root. Which to 5dp then, is, well, if you did this number here to 5dp, you get 0.80156. If it lies in between, to 5dp it's going to equal 57, isn't it? Anything in between this interval rounded to 5dp, which is where the root lies, is a root and is 80157, 0 point.